Alright guys, so we're going through the review video, or the review sheet here for chapter 4. So I'm going to go through all the problems here. Now the first three problems state the degree and leading coefficient. So the degree is the variable exponent. So we look for the variable with the biggest exponent. Here it's x to the 8. So it's telling us that the degree of the function is that number there. So it's going to be 8. Now the leading coefficient is the number in front of the variable with the biggest exponent. In this case, it's negative 27. So it's not always going to be the number, the first variable, that first term, but it is going to be the variable with the biggest exponent. In this case, x to the 8, degree is 8, leading coefficient is negative 27. Now, if we look at number 2, we look through this here. You need to look through the whole equation just in case it's not written in standard form. Here it is written in standard form. We know it's written in standard form because the variable's exponents decrease from biggest to smallest to our constant term. So the variable with the biggest exponent is our x to the 4th, telling us that the degree is 4. Leading coefficient is going to be the number in front of the variable with the biggest exponent, telling us it's 6. And our last one here, 4x to the 6, negative 27x to the 4th, 4x cubed, negative 27x to the 7th, 14. They hid the biggest exponent right here. Now it tells us the degree is going to be 7. Leading coefficient is going to be the number in front of that variable with the biggest exponent, negative 27. Now most likely, stating the degree, leading coefficient, and determining if it is or is not a polynomial function are going to be put together on the test. So, determine if it's a polynomial function. If it is, state the degree and leading coefficient. They're probably all going to be put together. Now, problems 4 through 7 state evaluate each function for the given value. So we're given this equation, and we're going to replace every x in this with negative 4. So we replace every x in h of x with negative 4. At this point here, I just grab the calculator. Just grab it there, and let's type the whole thing in. Negative 3, parentheses, negative 4 to the 4th, plus 2 times negative 4 to the 3rd, minus 12 times negative 4. That should be minus 6. And we should get negative 854, which we do. 854. So the answer for this one here is negative 854. We can do the same thing with number 5. We're replacing every x in f of x, or g of x in this case, with negative 7. So we have negative 7 cubed, plus 3 times negative 7 squared, plus 5 times negative 7, plus 1. And again, I just go back to the calculator. Negative parentheses, negative 7 cubed, plus 3 times negative 7 squared, plus 5 times negative 7, plus 1. Enter. And it tells us that it's 456. So the answer for this here is 456. For number 6, p of x. And we want to know when x is 8. So again, all we're doing is just replacing every x in p of x with 8. And after we do that, we're just going to take the calculator and type it in. 8 to the 6th minus 64 times 8 to the 4th plus 8 squared minus 8, or 7 times 8 minus 51, which will give us negative 43. And lastly, for number 7, 5 times negative 12 cubed minus 3 times negative 12 squared plus 2, make sure we write the 2, times negative 12 plus 4. And you replace that, or the number, with the variable, replacing that x with negative 12. I would definitely put the negative 12 in parentheses every single time, just to make sure that the exponents in that negative are used properly. All right, times negative 12 cubed minus 3 times negative 12 squared plus 2 times negative 12 plus 4 is negative 9,092. And yes, I think it would be a good idea to write it out with the number filled in, because it lets me know that you do know how to do this, you do know how to plug it in, and most likely it was a calculator error, but I would write it out. Now that does bring us through to problems 8 through 10. Determine if the following function is a polynomial function. If it is, we say yes. If it's not, we say no. Because we know it's a polynomial function if exponents attached to variables aren't, because they can't be negative fractions variables. Because the exponent can't be negative, it can't be fractional, it can't have variables in the exponents. 2, let's say, 2 different variables can't be multiplied together. And variables can't be in radicals or on bottom of a fraction. Because if any of these, because if we do have variables or exponents attached to variables that are negative, didn't mean to do that. Okay, never mind. Can't be, if we have a negative exponent attached to a variable, if we have fractions in the variable, in the exponent attached to the variable, or variables in the exponent attached to variables, it's not going to be a polynomial. Realistically, also, we could say that variables cannot be in the exponent. Variables can't be exponents. Exponents. Probably misspelled that. Exponents. Because if any of this shows up, then no. Because if we look at the first one, we do have that negative attached to a variable, that negative exponent. So, not a polynomial. Number 10, we have a fraction in the exponent attached to a variable. So this is also not a polynomial. If we look at number 9, it is written in, there are no fractions in the exponent attached to variables. We don't have negatives in the exponent attached to variables. We don't have variables in the bottom of a fraction. We don't have two different variables being multiplied together. And we don't have variables in exponents, period. So yes, this is a polynomial function. And on the test, we're going to most likely have to state the degree. Degree is the variable with the biggest exponent, that exponent, 3. Leading coefficient is 6. So even though this problem on the review didn't ask for it, but on the test it's going to ask you to determine whether or not it is a polynomial function, and then state the degree and leading coefficient. Here's another way to write these, another way to look at them, but it is the same thing. For problems 11 through 19, simplify. We're going to simplify. We're going to add, subtract, multiply, divide, or add, subtract, and multiply. You can add or subtract vertically or horizontally. It really doesn't matter. I would just pick the way that you're more comfortable with. I'm going to do all of these horizontally. Now the nice thing is because there is nothing in front of our first set of parentheses, we can just drop them. Since we're adding, we don't have to change the signs of our second set of parentheses. So it's going to stay negative 2x cubed squared minus 3x plus 2. Now at this point here, we're going to combine like terms. 3x squared minus 2x squared is going to be x squared. 4x minus 3x is going to be plus x. And negative 1 plus 2 is going to be plus 1. Telling us that our final answer is going to be x squared plus x plus 1. And that's it. We're just adding, we're combining our like terms. 12, we're doing the exact same thing, and it is also addition. So all we're going to have to do first is just drop the parentheses and then combine like terms. Excuse me. I always start with the exponent with the variable with the biggest exponent, so 12x to the fifth, because there is no other x to the fifth terms. So there's nothing to combine with it. It stays 12x to the fifth. The next one I'd be looking at is x to the fourth. We do have 2x to the fourth terms. Negative 2x to the fourth and 8x to the fourth. Negative 2 plus 8 is going to be positive 6x to the fourth. Then I'd look for my x cubed term. We only have one, negative 3x cubed. We just put it there. Then I would look for x squared. There are no x squared terms, so we're just going to move on to x. We have negative 2x, or not negative 2x. We have positive 2x and positive 4x. 2 plus 4 is going to be 6x. And then lastly, we have negative 5 plus 1 is negative 4, telling us our final answer is negative 12x to the fifth plus 6x to the fourth minus 3x cubed plus 6x minus 4. Now this answer on the review sheet, it looks like it cut the minus 4 off, but it is minus 4. And lastly, number 13 on this page here. This time we are subtracting. Now the first set of parentheses, because there is no sign or no number in front of it, it's just going to stay the same. We can just drop those parentheses. Now our second set of parentheses, we're going to have to distribute that negative through. The sign of everything inside this parenthesis is going to have to change. Since 2x to the fourth was positive, it's now negative. 3x cubed was positive, it's now negative. Negative x squared is going to become positive x squared. Positive x is going to become negative x, and negative 4 is going to become positive 4. Now at this point here, we're going to combine our like terms. X to the fourth, x to the fourth. So 7x to the fourth minus 2x to the fourth. 7 minus 2 is 5, giving us 5x to the fourth. Negative 9x cubed, negative 3x cubed. Negative 9 minus negative 3 is going to be negative 12x cubed. Negative 4x squared, positive 1x squared, negative 4 plus 1 is going to be negative 3x squared. Positive 5x, negative x, 5x minus x. 5 minus 1 is going to give us positive 4x. And lastly, 6 plus 4 is going to give us plus 10. Telling us that the solution to this subtraction problem is 5x to the fourth minus 12x cubed minus 3x squared plus 4x plus 10. And the reason I'm writing and doing these colors is to make sure I'm telling myself what is like terms, what are the same. Now that brings us to our last addition and subtraction problem. We're going to look at this one here for number 14. And again, the first set of parentheses, there's nothing in front of it. And because there's nothing in front of it, we just have to drop the parentheses, and everything inside these parentheses stays the same. Now we have to distribute that negative to our second set of parentheses. So our positive 2x to the fourth is going to become negative 2x to the fourth. Our positive 6x cubed is going to become negative 6x cubed. Our positive 2x is now negative 2x, and our negative 9 is going to become plus 9. Now, at this point here, we need to start combining like terms. So I start with the variable with the biggest exponent. Here, looking through the entire equation, x to the fourth is our term with the biggest exponent. 11x to the fourth minus 2x to the fourth, 11 minus 2 is going to give us 9x to the fourth. Now we would look for x cubed. Well, there's only one x cubed term in the entire equation, and that's our negative 6x cubed, so we can go on and just put down negative 6x cubed. There's nothing else to combine with it, so we just fill it in. Then we would go to our x squared terms. I have negative 9x squared. That's it, so it's minus 9x squared. Then we move to our x terms. We have 3x and negative 2x. 3 minus 2 is 1, so positive 1x. And lastly, our constant terms. 11 plus 9 is going to give us plus 20. Telling us that we have 9x to the fourth minus 6x cubed minus 9x squared plus x plus 20. Yep. Now that brings us to our multiplication problems, our distributive property. For number 15, we'll just jump right in. We're going to distribute through. We're going to multiply through. So we're going to multiply the 6x cubed by each term. Now, because it's only one term, we're going to multiply it through this other one here. So we have 6x cubed times 2x cubed. 6 times 2 is 12. X to the third times x squared. When we multiply those like bases, we add the exponents. So 3 plus 2 is 5, telling us it's 12x to the fifth. 6x cubed times negative 27x. Well, positive times a negative is going to be a negative. Now, at this point here, I'm just going to grab the calculator, say 27 times 6. 162. So 6 times negative 27 is going to be negative 162. X cubed times our x. 3 plus 1 is 4, telling us it's x to the fourth. And lastly, 6x cubed times 4 is going to be positive 24x cubed. We can't do the whole multiplication in the calculator, but we could at least do 6 times 4. And it does tell me it's 24. So the final answer for this here is 12x to the fifth minus 164x to the fourth plus 24x cubed. Now with 16, we do have a little more multiplication because we're going to have to distribute. We're going to start with the 2x. 2x times 2x squared, 2 times 2 is 4. X times x squared would be x cubed. 2x times 5x, 2 times 5 is going to be positive 10. Our x times x is x squared. And lastly, 2x times 8, 2 times 8 is 16. And we do still have that x. Now we're going to do this again and multiply with the 4. 4 times x squared is going to be plus 8x squared. 4 times 5x, 4 times 5 is going to be 20. We still have our x. And lastly, 4 times 8 is going to be plus 32. And lastly, we need to combine like terms. Now 4x cubed is the only term with x cubed. Then we move on to x squared. 10x squared plus 8x squared. 10 plus 8 is going to be plus 18x squared. 16x plus 20x, 16 plus 20 is 36x. And lastly, our positive 32 is the only number without a variable, so it just gets added to the end, giving us 4x cubed plus 18x squared plus 36x plus 32. Now that is a good question. Why don't we look at like terms on the previous one? Well, if we look at the one that we did before it, x to the fifth, x to the fourth, x to the third, there are no like terms here, so there was nothing to combine. So I just kind of glossed over that fact. Here, because we did have like terms listed here, I definitely underlined the wrong matching ones, but we do have like terms with our x squared and x squared, x and x, so we did have to combine those. All right, we're looking at problem number 17. Again, all this is a distributive property. You just need to work at one step at a time. Here we've got a 3 term and 3 term, a trinomial and a trinomial. So we're just going to start off with 3x cubed times x squared. We still have 3. X cubed times x squared would be x to the fifth. 3x cubed times negative 2x. 3 times negative 2 would be negative 6. X cubed times x would be x to the fourth. And 3x cubed times 1 is positive 3x cubed. So that takes care of our first term. Now we're going to move on to our negative 9x and distribute it across all three. Negative 9x times x squared is going to be negative 9x cubed. Negative 9x times negative 2x, and negative 9 times negative 2 is going to be positive 18. And our x times x is x squared. And lastly, negative 9x times positive 1 is just going to be negative 9x. Now that brings us to our last multiplication, our positive 7. 7 times x squared is going to be positive 7x squared. Positive 7 times negative 2x, positive 7 times negative 2 would be negative 14. We still have our x. And 7 times 1 is going to be plus 7. And lastly, we're going to combine our like terms. So we have 3x to the 5th. There are no other like terms with x to the 5th. Now I would look at my x to the 4th. And again, there are no other x to the 4th terms, so it's just minus 6x to the 4th. Now, pick this color. X cubed, we have 2. 3x cubed minus 9x cubed. 3 minus 9 would be negative 6x cubed. Then we do have x squared terms. We have 18x squared and 7x squared. 18x squared plus 7x squared. 18 plus 7 would be plus 25x squared. Then we move on to our x terms. We do have 2. Negative 9x minus 14x. Negative 9 minus 14 would be negative 23x. And lastly, our constant term of 7 plus 7. There are no other like terms. So we just add it on to the end, telling us that the final answer is 3x to the 5th minus 6x to the 4th minus 6x cubed plus 25x squared minus 23x plus 7. Now that brings us to 18 and 19. 18 and 19, we're just doing distributive property. So we're going to multiply 2 at a time. I'm just going to multiply these first two here. So the first thing we're going to do is distribute the 4. 4 times 1 is 4. 4 times negative 2x. 4 times negative 2 would be negative 8. And we still have that x. And we're going to do the same thing with negative 5x. Negative 5x times 1 is going to be negative 5x. Negative 5x times negative 2x. Negative 5 times negative 2 is going to be positive 10. X times x is x squared. Now we haven't done anything with the 3x plus 2, so we're going to just stick it on there at the end. Now we do need to combine some like terms. 10x squared, variable with the biggest exponent, we always want to put it first. Negative 8x minus 5x, negative 8 minus 5 is going to be negative 13x plus 4. And lastly, now that we finished combining like terms, we can do our last multiplication. We can multiply these two here. 10x squared times 3x. 10 times 3 is 30. X squared times x would be x cubed. Now because we're doing our last multiplication, there's nothing else to multiply this by. We're not going to put parentheses again. Now 10x squared times 2, 10 times 2 is going to be positive 20. We still have the x squared. Now we're going to multiply through with our negative 13x. Negative 13x times 3x. Negative 13 times 3 is going to be negative 39. And our x times x is going to be x squared. Negative 13x times 2, negative 13 times 2 is going to be negative 26. And we still have our x. And lastly, we're going to distribute the 4. 4 times 3x. 4 times 3 is going to be 12. But we do have our x. And lastly, 4 times 2 is going to be plus 8. Now that we've finished doing all the multiplication, we do need to combine like terms. 30x cubed is the only one with x cubed. So there's nothing to combine with it. Our x squareds, we do have 2 of them. 20x squared minus 39x squared. 20 minus 39 would be negative 19x squared. Our x terms come up next. We do have 2 of them. Negative 26x plus 12x. Negative 26 plus 12. Negative 14x. And lastly, our constant term of 8. And even with these here, 20x squared minus 39x squared, I can do 20 minus 39, negative 19, which is what we got, negative 26 plus 12 is negative 14. We can plug the coefficients, we can plug the numbers in front of those variables into the calculator. We cannot plug the variable in because the variable in the calculator has to have a specific value, a number value. Here, it is just represented as a variable. It doesn't have a specific value. So, can't plug the variable in, but I can plug the coefficients. I can plug the numbers in front of the variables in. 19, we got one more that we're doing multiplication before we start doing the division problems. Here we have x minus 2 times 3x plus 1. We're going to multiply these two first. And once we get our result, we'll multiply with our 4x minus 3. First thing I'm going to do is distribute this x. X times 3x is going to be 3x squared. X times 1 is going to be plus x. Now we're going to do the same thing with negative 2. Negative 2 times 3x, negative 2 times 3 is going to be negative 6. Still have that x. And negative 2 times 1 is going to be negative 2. Now before we do our multiplication, for the next step, we do need to combine these x terms. So we still have 3x squared because it doesn't have any like terms. X minus 6x would be minus 5x minus 2 times our 4x minus 3. Now that we've simplified, we can do our last multiplication. We'll distribute the 3x squared first. So 3x squared times 4x. 3 times 4 is going to be 12. X squared times x is going to be x cubed. 3x squared times negative 3. 3 times negative 3 is negative 9. Still have that x squared. Now we're going to move on to 5x. 5x times negative 5x times 4x. Negative 5 times 4 is going to be negative 20. X times x is going to be x squared. And then negative 5x times negative 3. Negative 5 times negative 3 is going to be positive 15. Still have that x. And lastly, we're going to distribute this negative 2. Negative 2 times 4x is negative 8x. And negative 2 times our negative 3 is going to be positive 6. Now we're going to finish with combining our like terms. 12x cubed does not have any like terms. Negative 9x squared and negative 20x squared. Negative 9 minus 20 is going to be negative 29x squared. And our next term is our x terms, 15x minus 8x. 15 minus 8 is going to be positive 7x. And then our constant term is by itself, so we just added on to it, giving us plus 6. Telling us that it's 12x cubed minus 29x squared plus 7x plus 6. And that's it. Now the next thing we have is to divide the two polynomials by synthetic division or long division. I am giving you the option, especially on the test. You get to pick which option or which one you want to do. If you want to do synthetic division or long division, you have to pick which one. There is not a requirement that you have to do one or the other. But this first one here, I'm going to do it both. So I'm going to do long division first. So we set up our problem for long division. Our expression, our polynomial expression that's being divided by goes inside. So we have x cubed minus 10x squared plus 20x plus 26. If a term is missing, we have to fill it in. Our biggest term is x cubed, so we need an x cubed, x squared, x constant term. We need one more term than the degree. Degree is 3, so I need 4. 1, 2, 3, 4, they're all there. What we're dividing by has to go in front. Now that we've set it up, we take the first part of the process. We take the biggest term inside of what we're dividing it. In this case, it's x cubed, divided by the biggest term outside. So for this first part here, we have x cubed divided by x. X cubed divided by x is going to be x squared. When we divide like bases, we subtract the exponents. So 3 minus 1 is 2, telling me that it's x squared. So that's our first part of our answer. And we put it above our negative 10x squared, it's like term. At this point here, we're going to multiply the x squared by what we're dividing this by, x minus 5. Now we have to distribute. X squared times x is x cubed. X squared times negative 5 is negative 5x squared. Once we finish doing that, we put it under their like terms. So x cubed minus 5x squared. And then for long division, we subtract. Synthetic division is where we add. Now we're going to go through and subtract. So our first one is going to be x cubed minus x cubed. X cubed minus x cubed is 0. Negative 10x squared minus negative 5x squared. Well, the negative and negative make a positive, so negative 10x squared plus 5x squared would be negative 5x squared. Now there's nothing else to subtract, so we bring down our next term. And repeat this process. We take the biggest term inside, which is now negative 5x squared, and divide it by the biggest term outside, which is just x still. And it will be just x for this entire problem. Now at this point here we divide. Negative 5x squared divided by x is going to be negative 5x. So the next part of our answer is negative 5x. And again, we multiply. Negative 5x times our x minus 5. Negative 5x times x is going to be negative 5x squared. Negative 5x times negative 5, the negative and negative make a positive. 5 times 5 is 25. We still have our x. Telling us that we have negative 5x squared plus 25x. And again, once we get this set up, we're going to subtract. Negative 5x squared minus negative 5x squared. Well, the negative and negative will make a plus. Telling me I have negative 5x squared plus 5x squared. Negative 5 plus 5 is indeed 0. They cancel out. 20x minus 25, 20 minus 25 is going to be negative 5x. Now we bring down the constant term, and we do this one last time. Biggest term inside is negative 5x. Biggest term outside is still x. And negative 5x divided by x is going to be negative 5. And just like before, we take the negative 5 and multiply by our x minus 5. Negative 5 times x is negative 5x. Negative 5 times negative 5 is plus 25. And again, we put it underneath. And just like before, we're going to subtract. Negative 5x minus negative 5x. The negative and negative make a plus. Tell me I'm negative 5x plus 5x, which is indeed 0. 26 minus 25 is 1. I did forget to put the negative 5 up here. But that brings us to the end, and our 1 is our remainder. If we have a remainder, we have to add it back to our answer. The remainder goes on top of the fraction, and what we were dividing this by goes on bottom. Telling us that our final answer for this problem here is x squared minus 5x minus 5 plus 1 over x minus 5. And that's how we would go about solving this division problem here. Take 2. We're going to do this again, but with synthetic division. If I'm dividing this by synthetic division, we'll take what is being divided it by, x minus 5, we set it equal to 0, and then solve for the variable with the biggest exponent, in this case x. And to do that, we add 5 to both sides, telling us x is equal to 5. Now we need that for the problem because the number in the cubby is going to be this 5. Then we take the coefficients of what's being divided by, or divided, and put them across the top. Now we're going to have 1 for our x cubed, negative 10 for x squared, 20 for x, and 26. Now because we do have every term, we don't have to, we don't have to fill any of the missing terms in as 0. Now at this point here, we're going to multiply and then add. So the first thing we want to do is multiply the term inside the cubby with the number below the line. So we're going to have 5 times 1, which is 5. And then we take that number and put it above the line and below the next number. Okay. Let's see here. So take it and put it up here, giving us 5. Move that down there and out of the way. Now we add straight down. So negative 10 plus 5 is negative 5. Now we're going to repeat this process again. So we're going to take our 5 inside the cavity and multiply with the number below the line. So we'll have 5 times negative 5, which is going to be negative 25. And then we're going to take that number and put it below our next one. So negative 25 goes here. And after we do that, we're going to add 20 and negative 25. And 20 plus negative 25 is, well, negative 5. Then we're going to do this again. We'll take our 5 and multiply it by our negative 5. Well, we already have it here. Negative 25. And then lastly, we're going to add straight down. 26 plus negative 25 is 1. The number inside the box is our remainder. The first negative 5 is our constant term. Our second negative 5 is our term with x, and our 1 is our term with x squared. Telling me my final answer is x squared minus 5x minus 5 plus our remainder over what we're dividing it by. And it's not going to be the 5. We're dividing it by x minus 5. So we have to actually put it in as x minus 5. I'm going to rewrite that again. And it tells us that this is the final answer. If you notice, that is the exact same answer we got for long division. So it doesn't matter if we do long division or synthetic division, it will get us to the same result. Let's look at number 21. X cubed minus 13x squared plus 40x plus 18 is being divided by x minus 7. So I'm going to do this by synthetic division. And again, biggest term inside divided by biggest term outside. So x cubed divided by x is going to be x squared. And that's the term we put on top. And we multiply this term by our x minus 7. And I do that work off to the side. X squared times x minus 7. X squared times x is going to be x cubed. X squared times negative 7 is negative 7x squared. And we're going to take that and put it underneath. So we have x cubed minus 7x squared. We're going to take that and subtract. X cubed minus x cubed is going to be 0. Negative 13x squared minus negative 7x squared. The negative and negative make a plus. So negative 13 plus 7x squared. Now, I could do this in a calculator. I can't plug the variable in, but I could say negative 13 minus negative 7, negative 6, or negative 13 plus 7 is still negative 6. So it tells us that we have negative 6x squared. Now, since we finished our subtraction, we drop the next term down and do this again. Biggest term inside this time is negative 6x squared. Biggest term outside is still just x. So negative 6x squared divided by x. Our x squared over x would simplify to just x. And we still have the negative 6. Telling us our next term is negative 6x. And again, we're going to multiply the negative 6 by what's outside. So negative 6x times our x minus 7. Negative 6x times x is going to be negative 6x squared. Negative 6x times negative 7. The negative and negative make a plus. 6 times 7 is going to be 42, and we have our x. And we take that and put it underneath its like terms. And again, we're going to subtract. Negative 6x squared minus negative 6x squared. The negative and negative make a plus, so negative 6 plus 6 is indeed 0. 40x minus 42x, 40 minus 42 is going to be negative 2x. We bring down the plus 18 and we do this one last time. Biggest term inside now is negative 2x. Biggest term outside is still x. So negative 2x divided by x, or x divided by x simplify out, leaving us with just negative 2. And one last time, we're going to multiply the negative 2 by what's outside, our x minus 7. So negative 2 times our x minus 7. Negative 2 times x is going to be negative 2x. Negative 2 times negative 7 is going to be positive 14. Telling us that we have negative 2x plus 14. And again, we're going to subtract. Negative 2x minus negative 2x. Well, our negative make a plus, so negative 2x plus 2x is 0. 18 minus 14 is 4. So this here is our remainder. We do have a remainder we have to add back to the answer. So we have positive 4 over what we were dividing it by, x minus 7. Telling us that our final answer is x squared minus 6x minus 2 plus 4 over x minus 7. All right, take 2. We're going to do this again with synthetic division. Now, on the test, you just have to pick one of the two. You do not have to do it both ways. You just have to do it one or the other. So we're going to get it set up. First thing we need to do is solve for x. In this case, we're just solving for x, the variable with the biggest exponent. So we add 7 to both sides, telling us x is equal to 7. And it's the number that goes inside the cubby. Our numbers going across the top are our coefficients. 1 for x cubed, negative 13 for x squared, 40 for x, and 18. And we bring the 1 down. Now we're going to do the same process again. We're going to say 7 times 1 is 7. And we take it and put it above the number, above the line below our next number. And we're going to do this here. Then we're going to add. We're going to have negative 13 plus 7. We're going to add those two together. And when we add those two together, we get negative 6. Then we're going to multiply 7 and negative 6. And 7 times negative 6 is negative 42. We're going to take that negative 42 and put it under our next number, right there. Move those up out of the way. Okay. Well, it doesn't want to attach itself. We'll do that. Now, the next thing we're going to do is add straight down. We're going to add 40 and negative 42. Well, we can add it, or I can go 40 plus negative 42 is negative 2. We add these two, we get negative 2. And we're going to do this one more time. We're going to multiply our 7 and negative 2. We're going to multiply those two together. 7 times negative 2 is going to be negative 14. And then we're going to take this negative 14 and put it under the last number. We're going to put it under this 18. And then we're going to add straight down. So the last thing we're adding is this 18 and negative 14. Really, we can say 18 minus 14. And 18 minus 14 is not going to be negative, it's just positive 4. Write that again. And that's it. Now, because we're only dividing by 2 terms, our remainder is a single term, just the 4. So this here is our remainder. Our negative 2 is our term without x. Negative 6 is our term with x, and 1 is our term with x squared. Telling us that we have x squared minus 6x minus 2 plus the remainder of 4 over what we were dividing this by, x minus 7. It's not just the number positive 7, it's what we were dividing it by originally, our x minus 7. And we get this here. Now we're going to move on to this next one here. 7x to the fourth minus 10x cubed plus 3x squared plus 3x minus 3. We're going to divide it by our x minus 1. We got it set up, so we're going to start our process. I'm going to take the biggest term inside, divided by the biggest term outside. Well, we'll still have 7 because we're mainly just dividing that x to the fourth by x. X to the fourth divided by x is going to be x to the third. Then we take that and multiply it by what's outside, so 7x cubed times our x minus 1. 7x cubed times x is going to be 7x to the fourth. 7x cubed times negative 1 is going to be negative 7x cubed. Now we take that and put it underneath their like terms. And then we're going to subtract. 7x to the fourth minus 7x to the fourth is 0. Negative 10x cubed minus negative 7x squared, the negative and negative make a plus, telling us that we have negative 10x cubed plus 7x cubed. Negative 10 plus 7 is going to be negative 3x cubed. Bring down our next term, plus 3x squared. Now at this point here, we're going to just repeat the process. We're going to do this again. Biggest term inside is now negative 3x cubed. Divided by the biggest term outside is just x. Still have negative 3. X cubed divided by x is going to be x squared. And again, we're going to multiply the negative 3x squared by what's outside our x minus 1. Negative 3x squared times x is going to be negative 3x cubed. Negative 3x squared times negative 1, the negative and negative make a plus. 3x squared. We put it underneath. Negative 3x cubed plus 3x squared. And then we are going to subtract. Negative 3x cubed minus 3x cubed. The negative and negative make a plus. Negative 3 plus 3 is 0. Our next one, 3x squared minus 3x squared, is also 0. So we bring down our next term, 3x. Now this is interesting because these zeroed out, that's fine. It's all 0. But I only have one term here. So I can't be able to divide if I wanted to. It would just be saying that plus 0x. But what we're going to do instead is just going to bring down the negative 3. Because I have two terms I'm dividing it by, I need two terms here. So we can go on and move to the next step. Our biggest term inside divided by our biggest term outside. I got ahead of myself. It's not the biggest term outside is not 3, it's just x. But 3x divided by x is indeed 3. And then we're going to multiply what's outside, or what's on top by what's outside. So 3 times our x minus 1. 3 times x is 3x. 3 times negative 1 is negative 3. And last but not least, we subtract. 3x minus 3x is 0. Negative 3 minus negative 3, the negative and negative make a plus. 3 plus 3 telling us that the remainder is 0, meaning this divides evenly. So 7x cubed minus 3x squared plus 3 is our final answer. All right. Take 2. We're going to set what's being divided, what we're dividing this by, equal to 0, and solve. And again, we're just solving for x in this case. Those cancel, telling me x is negative 1. And negative 1 is our number that goes in the cubby. And then we take our coefficients going across the top, starting with 7 for x to the fourth. Negative 10 for x cubed, 3 for x squared, 3 for x, and negative 3. If a term is missing here, if a term is missing there, x to the fourth is our biggest one, so x to the fourth, x cubed, x squared, x constant. If one of them's missing, it's not there, we have to fill it in as 0. Since the degree is 4, we should have 1, 2, 3, 4, 5. We need one more term than the degree. So just be paying attention to that. Now we're going to start this process. Negative 1 times 7 is going to be negative 7. We put it under the next one. I'm just going to go on and jump through this here. Negative 10 plus negative 7 is negative 17. Then we're going to do negative 1 times negative 17. Negative 1 times negative 17 is going to be positive 17. Add straight down. 3 plus 17 is going to be 20. Then we're going to do negative 1 times 20. And negative 1 times 20 is negative 20. Then we're going to add straight down. 3 plus negative 20 is negative 17. Sure. 20. 22. 7 I agree with. Why is it giving me something different? Oh. Error. Right here. Error. It should be x minus 1 equals 0, not x plus 1. I am sorry. That's my mistake. Because we're supposed to add 1 to both sides. Negative 1 plus 1 is 0, telling us x is 1. So it should be positive 1. 7 for x to the 4th, negative 10 for x cubed, 3 for x squared, 3 for x, and negative 3. We'll bring down the 7. We'll do this process again. 1 times 7 is going to be positive 7. Then we're going to add straight down. This looks better. Negative 10 plus 7 is negative 3. Then we're going to multiply 1 times negative 3. Well, it is negative 3. Then we add. We're going to add our 3 and negative 3, and 3 plus negative 3 is 0. Then we're going to multiply our 1 times 0. We're going to multiply that 1 times 0, and, well, that's 0. Yep. Then we're going to add straight down. We're going to add the 3 and 0. We're going to add those two together. Adding those two together, and 3 plus 0 is 3. And lastly, we're going to multiply 1 times 3. Our 1 times 3 is positive 3. Last but not least, we're going to have negative 3 plus 3. And negative 3 plus 3 is indeed 0. Dividing by 2 terms, so our last term is the remainder. Our 3 is our term without x, 0 is our term with x, negative 3 is our term with x squared, and 7 is our term with x cubed. Telling us we have 7x cubed minus 3x squared plus 3. Now we know the 3 is positive because there's not a sign in front of it, so it's understood to be positive. 23. Again, we've got 2 more division problems. So we're going to divide these here. X squared plus 4x minus 2. We have 2x to the 4th inside, positive 8x cubed minus 5x squared minus 4x plus 2. And again, there is a term missing here. We have to fill it in as 0x to that power. We cannot have any missing terms. And our first step is still going to be the same. We're going to take the biggest term inside and divide it by the biggest term outside. So 2x to the 4th is our biggest term inside. X squared is our biggest term outside. So we're going to divide these two here. We'll still have 2, but x to the 4th divided by x squared is going to be x squared. Telling us our first term on top is 2x squared. Now we're going to take that and multiply it by what's outside. So we're going to have 2x squared times our x squared plus 4x minus 2. 2x squared times x squared is going to be 2x to the 4th. 2x squared times 4x, 2 times 4 is going to be plus 8. X times x squared is x cubed. And 2x times negative 2 is going to be negative 4x squared. And we're going to take this and put it underneath. They're like terms. 2x to the 4th plus 8x cubed minus 4x squared. And then we're going to subtract. 23. Now 2x to the fourth minus 2x to the fourth, 2 minus 2 is 0, so they cancel out. Look at this, 8x cubed minus 8x cubed, 8 minus 8 is also 0. Negative 5x squared minus negative 4x squared, well, the negative and negative make it positive, so negative 5 plus 4 gives us negative 1x squared and negative x squared. We bring down our next term. Now, incidentally, because again, 2 canceled out, what we're dividing by, or what we have underneath next, only has 2 terms. We needed to have 3. So in order to have 3, we bring down the next term, plus 2. And we do this process again. Biggest term inside is negative x squared. Biggest term outside is x squared. So negative x squared divided by x squared is going to be negative 1. Now at this point here, we're going to take what's above the line and multiply it by what's outside. So we're multiplying negative 1 by x squared plus 4x minus 2. Negative x times, or negative 1 times x squared is negative x squared. Negative 1 times 4x is negative 4x. And negative 1 times negative 2 is going to be positive 2. Interesting, it looks like they're the exact same, so this will probably simplify to 0. Let's see. Negative x squared minus negative x squared. Well, the negative and negative make a plus, telling us negative x squared plus x squared is indeed 0. 4x minus negative 4x. Well, our negative makes a plus, so negative 4x plus 4x is indeed 0. And lastly, 2 minus 2 is 0, telling me that the remainder is 0. And 2x squared minus 1 is our final answer. And that's all we have to do for this here. Now, if you're wondering, yes, we can do this by synthetic division. It does take a little bit longer to set up, but we are able to do it. Our cubby is a little bit longer, and we do have 2 lines instead of 1 line because we're going to have 2 numbers inside the cubby. We take what we're dividing this by, x squared plus 4x minus 2, set it equal to 0, but this time we're having to solve for x squared. We're having to get the x squared term by itself. So the first thing we can do in this is add 2 to both sides. Minus x squared plus 4x is equal to 2. Then we're also going to have to move the 4x over. We're going to subtract 4x. Telling us that we have x squared is equal to negative 4x plus 2. And we're going to take 2 coefficients. We're going to have the negative 4 and the 2. I'm going to put them in different colors. I'm going to put negative 4 as this maroon and 2 as this here. Now we're going to take the numbers calling our coefficients of what's being divided. So 2 for x to the fourth, 8 for x to the third, negative 5 for x squared, negative 4 for x, and 2. We bring the first number all the way down. We bring the second number down 1. And we're going to start this product. Now we multiply the negative 4 terms. The values we multiply are going to be put above the second line. The second number is going to go above the first line. And it's all going to be multiplied by the bottom number. So the first thing we're going to multiply is negative 4 times 2. And negative 4 times 2 is negative 8. And it's going to go right there. Move that over there. And then we're going to do 2 times 2, which is 4, and put it right there. Move that out of the way. Then just like before, we're going to add straight down. So the first thing we can add is 8 plus negative 8. We can add those 2 together. And 8 plus negative 8 is 0. Next ones we can add is this negative 5 plus 4, this negative 5 plus 4 here. And negative 5 plus 4 is negative 1. And we're going to do this process again. We're going to say negative 4 times 0. Well, negative 4 times 0 is 0. And I do put it above that bottom line under our negative 1. And then we're going to do the same thing with negative, or a positive 2. And do positive 2 times 0, which is 0. And we put it above the line, above that first line, under our next number, under that 4. And then we're going to add this negative 4 plus 4. We're going to add these two values together. Negative 4 plus, sorry, negative 4, not negative 4 plus 4. Negative 4 plus 0 Negative 4 plus 0 is negative 4. I forgot to add these two here, negative 1 plus 0, because we also have to add these two before we can do our next step. Negative 1 plus 0 is negative 1. We need to do this one more time. And again, now we're going to multiply our negative 4 and negative 1. We're going to multiply those together and get negative 1. And then we're going to multiply our 2 and negative 1. And 2 times negative 1 is negative 2. And lastly, we're going to add. We're going to have to add negative 4 plus negative 1. Back up. What was I even saying? I think I spaced out for a second. Negative 4 times negative 1 is not 0. Don't know where I got the 0 from. But negative 4 times negative 1 is 4. 2 times negative 1, I had that right, it is negative 2. Now we're going to add straight down. We're going to add these down. Do make sure you're paying attention to what you're multiplying and making sure it's the right things and not just numbers. Now we add these two together. Negative 4 plus 4 is 0. 2 plus negative 2 is also 0. Since I don't have any other numbers here after what we're dividing it by, we bring that last number down so that they're all on the same line. Since what we were dividing this by has 3 terms here, our remainder should have 2. So the last 2 terms, the last 2 numbers below the line are the remainder. And the first number inside the remainder is our constant term. The second would be our term with x. In this case, the remainder is 0, so that doesn't make a difference. What's outside? Our negative 1 is our constant term, our term without a variable. 0 is our term with x, 2 is our term with x squared. Telling me that my final answer is 2x squared minus 1. For some of this here, if we find this nice, do it this way. If you don't, do it by the long division. Do it by that method instead. Problem number 24. We have x squared minus x plus 3, and it's going to go outside. Inside, 3x to the 4th minus x cubed plus 8x squared plus 5x plus 3 goes inside. Take biggest term inside divided by biggest term outside, which is just x squared. 3x to the 4th divided by x squared. We'll still have 3, and x to the 4th divided by x squared is going to be 3x squared. Now we're going to take this and multiply what's outside. So 3x squared times x squared minus x plus 3. So we're going to distribute 3x squared times x squared is 3x to the 4th. 3x squared times negative x is going to be negative 3x cubed. And 3x squared times 3, 3 times 3 is going to be plus 9 x squared, and we can put that underneath. We can put that underneath here, so 3x to the 4th minus 3x cubed plus 9x squared. And again, at this point here, we're going to subtract. 3x to the 4th minus 3x to the 4th is going to be 0. Negative x cubed minus negative 3x cubed. Well, our negative and negative make a plus. So x cubed negative x cubed plus 3x cubed. Negative 1 plus 3 is going to be positive 2x cubed. 8x squared minus 9x squared. 8 minus 9 is going to be negative 1, so negative x squared. And then we bring down our positive 5x. There we go. Stop. Not really. Repeat the process. Our biggest term inside is 2x cubed. Our biggest term outside is x squared. 2x cubed divided by x squared is going to be positive 2x. So plus 2x. And then again, we're going to multiply it by what's outside. So we're going to have 2x times x squared minus x plus 3. And we're going to do this distributive process. 2x times x squared is 2x cubed. 2x times negative x is negative 2x squared. And 2x times 3 is going to be plus 6x. And we can put it underneath 2x cubed minus 2x squared plus 6x. And again, we're going to subtract. 2x cubed minus 2x cubed. 2x cubed minus 2x cubed is 0. Negative x squared minus negative 2x squared. Our negative and negative make a plus. Negative x squared plus 2x squared. So it'll be positive x squared. 5x minus 6x is negative x. And lastly, we bring down our plus 3. And we do this one more time. Biggest term inside is x squared. Biggest term outside is still x squared. And x squared divided by x squared is going to be positive 1. And again, one more time. Well, 1 times x squared minus x plus 3 is x squared minus x plus 3. And then lastly, we're going to subtract. So, I thought I made a mistake. No, we're good. X squared minus x squared is 0. Negative x minus negative x, the negative and negative make a plus. Negative x plus x is 0, and 3 minus 3 is indeed 0. That's our remainder. Telling us that 3x squared plus 2x plus 1 is the solution. Now I noticed that your review sheet and this here are off because I changed that from negative x cubed to positive x cubed. I just noticed that. So, really, I'm going to bring it all the way back here. Because up to this point, everything with this here so far is the exact same. The only thing that's going to change is that because in the problem this here is plus, it means that there has to be plus. It's going to change it a little bit. It's going to change it from here on down. 3x to the fourth minus 3x to the fourth is still 0. X cubed minus negative 3x cubed. Again, the negative and negative make a plus. X cubed plus 3x cubed is now 4x cubed. 8x squared minus 9x squared is still negative x squared. Bring down our plus 5x. So that one value is going to change everything. Because now our biggest term inside is 4x cubed. Our biggest term outside is still x squared. So instead of having 2x, we have 4x. So it's going to be plus 4x. We're going to take what's in front and multiply it by 4x. So we're going to have 4x times x squared minus x plus 3. 4x times x squared is 4x cubed. 4x times negative x is negative 4x squared. And 4x times 3 is plus 12x. And we put it underneath. And then we're going to subtract. 4x cubed minus 4x cubed is 0. Negative x squared minus negative 4x squared, our negative and negative make a plus. Negative x squared plus 4x squared is going to be positive 3x squared. 5x minus 12x, 5 minus 12 would be negative 7x. Bring down the plus 3, and we do this one more time. Okay, good. 3x squared divided by x squared is going to be positive 3. We're going to take that 3 and multiply by our x squared minus x plus 3. 3 times x squared is 3x squared. 3 times negative 3 is negative 3x. And lastly, 3 times 3 is going to be plus 9. 3x squared minus 3x plus 9. We're going to take this and subtract. 3x squared minus 3x squared is 0. Negative 7x minus negative 3x, then negative makes a plus. Negative 7x plus 3x would be negative 4x. 3 minus 9 is negative 6. So I did this to show that we do have a remainder, show us one with a remainder, that's negative 4x minus 6. So we're going to add negative 4x minus 6 over x squared minus x plus 3. That's why I made that change. I just did not make the change to the slides. And I have a feeling I've done that every year. I keep forgetting to change it. But this is the answer we get. Might as well. We've come this far. Let's do it with synthetic division also. Numbers across the top, 3 for x to the fourth. That should be plus, positive 1 for x cubed, 8 for x squared, 5 for x, and 3 for our constant term. Bring the 3 all the way down. Bring the 1 down 1. And we do still need to get our terms inside the bucket. Our cubby, we'll subtract 3 first. Minus x squared minus x is equal to negative 3. Add x. Minus x squared is equal to x minus 3. Our number in front of the x is 1. Constant term is negative 3, so we'll have 1 and negative 3. Now we're doing multiplication. Our 1s are going to go above the first line. Our 1 products are going to go above the bottom line. And our negative 3s products are going to go above the top line. So 1 times 3 is going to give us 3. Negative 3 times 3, positive 3, negative 3 times positive 3 is going to be negative 9. And then we're going to add straight down. Our 1 plus 3 here is going to give us 4. And then our negative 9 and 8, 8 plus negative 9 is going to be negative 1. Repeat the process. 1 times 4, our 1 times 4 is going to give us positive 4. Negative 3 times 4, negative 3 times positive 4 is going to be negative 12. And then we're going to add. We're going to add this negative 1 plus 4, negative 1 plus 4 is going to give us 3. Then we're going to add our 5 plus negative 12. 5 minus 12 is going to give us negative 7. We're going to do our product one more time. 1 times our 3 is going to give us 3. And negative 3 times 3 is still going to be negative 9. And then we're going to add straight down. We're going to add this negative 7 plus 3 first. Negative 7 plus 3 is indeed negative 4. And then we're going to add this 3 and negative 9. 3 plus negative 9 is negative 6. Now, because we don't have any other numbers up here to multiply or to work with, we bring the negative 6 down. Now, the last two numbers are our remainder, dividing by 3 terms, so the remainder should have 2 terms. So our negative 4 and 6 are a part of the remainder. Negative 6 is our constant term for the remainder. Negative 4 is our term with x in the remainder. Outside the remainder, 3 is our constant term. 4 is our term with x. 3 is our term with x squared. Minus our whole part is going to be 3x squared plus 4x plus 3. Then for the remainder, our negative 4x minus 6 goes on top. And what we were dividing this by, our x squared minus x plus 3 goes on bottom. And this here is our final answer for this piece here. Rational zeros. So our rational zeros are plus or minus p over q, where p is the factors of the constant term, and q is the factors of the leading coefficient. So our factors of p are going to be the factors of 27. Always start with 1 in the number, 1 and 27. 2 is not a factor of 27, but 3 is. 3 times 9. 4 is not a factor, 5 is not a factor. That is it. That's all the factors of 27. Q is the factors of the leading coefficient, the number in front of the variable with the biggest exponent. So we have 1 and 9, and 3 and 3. Now, even though 3 shows up twice, we're only going to write it once. And that's how we find the factors of P and Q. Now we're going to take all the factors of P and divide it by Q. So we're going to start off with 1 divided by 1, which is 1. 3 divided by 1 is 3. 9 divided by 1 is 9. And 27 divided by 1 is 27. Then we're going to move on and do the same thing with 3. We're going to have 1 over 3. 1 divided by 3 is 1/3. It's not listed, it doesn't reduce, so we have that there. Our next one is 3/3. 3 divided by 3 is 1. It does simplify to 1, and because we have 1 listed already, we're not going to write it again. Same thing with 9 divided by 3. 9 divided by 3 is 3. We already have 3, so we're not going to write it again. And lastly, 27 divided by 3 is 9. We already have it. We're not listing it another time. Then lastly, we're going to go to 9. So 1 over 9. So plus or minus 1/9. It doesn't reduce. We don't already have it listed, so we're going to write it there. 3/9. And again, we could do this in a calculator. 3/9 is 1/3. We have it listed. Not going to list it again. 9 over 9. 9 divided by 9 is 1. We have it. 27 over 9 is 3. We have it. So the only rational zeros for this here is plus or minus 1, plus or minus 3, plus or minus 9, plus or minus 27, plus or minus 1/3, and plus or minus 1/9. If you include extras that are just repeated, that's fine, but if you start including too many that do not exist, I will start counting points off on the test. Let's look at problem number 26. So it's going to be good to start with our factors of P and factors of Q first. P is our factors of the constant term. 15, I'm not worried about the negative, we're just worried about 15. So factors of 15, the numbers that multiply together to give us 15. 1 and 15, 3 and 5. We're just looking at the factors. Q, factors of the leading coefficient, the number in front of the variable with the biggest exponent, which is 12. So we have 1 and 12, 2 and 6, 3 and 4. So this time we have more factors of Q. That is perfectly fine. And once we find all the factors of P and all the factors of Q, we're going to divide every factor of P by each factor of Q. And I always start with 1. And really what that's going to do is just give us the factors of P back. So we have plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. And I'm going to move over to 2. So we have 1 over 2, which is 1/2. It doesn't reduce. We have 1/2. 3 over 2 is going to be 3/2. 5 over 2 is 5/2. And 15 over 2 is 15/2. None of that reduces, so we write it back out. Then we're going to move on to 3. We have 1 over 3, which is plus or minus 1/3. Now 3 over 3 is 1. That reduces completely to 1. We already have it. We're not going to list it again. 5/3 doesn't reduce. We don't already have it, so we're going to write plus or minus 5/3. And lastly, 15/3. 15 divided by 3 is 5. We do have it. We're not writing it again. Now we're going to move on to 4. So we have plus or minus 1/4. Then we're going to have 3 over 4, plus or minus 3/4. 5 over 4 is plus or minus 5/4. And then 15 over 4 is plus or minus 15/4. None of this reduces, none of it simplifies, none of it's been repeated, so we have to list them all out. Now we're going to do it again with 6. So plus or minus 1/6. Now 3/6 reduces to 1/2. We do have 1/2, so we don't have to write it again. 5/6 doesn't reduce. It's not repeated, so we have plus or minus 5/6. And lastly, 15 over 6 does reduce. And again, with any of these here, we could type these in and see if they reduce. They does. 5/2, we have 5/2. We don't have to write it again. And now lastly, we're going on to 12. So we have 1 over 12, so 1/12 doesn't reduce, it's still there. Now 3/12 reduces to 1/4, we have 1/4. 5/12 doesn't reduce, so we do have to list it. And lastly, 15/12 does reduce. We can say 15 over 12 is 5/4. We do have 5/4. I'm not going to reread all these out, but this is all of the possible rational zeros. 27 and 28, we want to find Descartes' rule of signs. We're going to use Descartes' rule of signs to find the possible number of positive and negative zeros. And to find that, we count the sign changes. So for our positives, we just count the sign changes. From x to the 5th to x to the 4th, it goes from positive to negative, so that's 1. X to the 4th to x third, negative, positive, that's 2. We go from positive to negative, that's 3. Negative to negative, we don't count it. But negative to positive gives us 4 sign changes. So the number of positive zeros is 4, or an even number less than it. So 4, 2, and 0. We just subtract 2 until we can't. Because 2, we subtract 2 from 0, we have a negative. We can't have negative positive amounts. Now to find the negatives, we need to look at f of negative x. And as I said, if the exponent's negative, or sorry, not negative, if the exponent is odd, change the sign. If the exponent's even, leave it alone. So x to the 5th, 6x to the 5th, because the 5th power is odd, we have to change it from positive to negative. Our next one is 27x to the 4th. 4th power is even, so we're going to keep it the same. Since it was negative, it's going to stay negative. Our next term is 56x cubed. 3rd power is odd, so we have to change the sign. It was positive. It's now negative. X squared, x to the power of 2. 2 is an even power, so we have to keep the sign the same. And since it was negative, it's going to stay negative. Our next one is 36x. It's really to the 1st power, which is odd, so we have to change that sign from negative to positive. 40 is our constant term. Since it doesn't have a variable, we don't touch the sign. And now we're going to count the sign changes. We're going from negative to negative, no sign change. Negative to negative, no sign change. Negative to negative, still no sign change. Then we're going from negative to positive, that's 1. Positive, positive, no. So our negatives, the possible negatives that we can have is only 1. Because if we tried to minus 2 from it, we get negative 1. Can't have a negative number of solutions. Now just finding those helps us start the table. Our table is our answer. I always start with the most of each. 4 positives, 1 negative. Which does give us a total of 5, so there's not going to be any complex. And the reason I know that there should be 5 is because the degree of the polynomial is 5, so the total number of solutions should be 5. Now at this point here, I subtract 2 from the negatives until I can't. Well, I just can't. And once that happens, I subtract 2 from the positives. So our next setup we can have is 2 positives, 1 negative, which is only 3. We need 5, so there would be 2 complex. And our last setup would be 0 positives, 1 negative, and 4. So that would be the possible rational zeros, or possible solutions according to Descartes' rule of signs. We have one more with Descartes' rule of signs, and then we have 30, 31, 5 more with solving, and then we are finished. Now our positives, we're just going to count the sign changes. Positive to negative is 1. Negative to positive is 2. Positive to negative is 3. Negative to negative, no. Negative to positive is 4. Positive to negative is 5. So the number of positives for this here is 5, 3, 1. Now to find our negatives, we need to find f of negative x. If the exponent's odd, we change the sign. If the exponent's even, leave it be. So 6x to the 7th, because the exponent's negative, we're going to have to change it from positive to negative. Our next one is 5x to the 5th power. Since the exponent's odd, we have to change the sign from negative to positive. Our next term is x to the fourth, 27x to the fourth. Since it's an even exponent, leave it be. Our next term is 30x cubed, odd power, so that means that sign has to change from negative to positive. Negative 20x squared. Since it was negative and an even exponent, it has to stay negative. Next one's 5x. Since that is an odd power, it's understood to be 1. We have to change it from positive to negative, minus 6. So since it's our constant term, doesn't change. Count the sign changes. Negative to positive would be 1. Positive to positive, no. Positive to positive, so no. Positive to negative would be 2. Negative to negative, and lastly, negative to negative. So our negatives for this here is most we can have is 2, or an even number less than it would be 0. Positive, negative, complex. So the most positives I can have is 5, 2 negatives. Now since the degree is 7, we should have 7, and 5 plus 2 does give us 7. We aren't missing any, so it'd be 5, 2, 0. Now at this point here, I would start subtracting 2 from the negatives. I can take 2 away from the negatives, giving me 0. Telling me I can have 5 positive, 0 negative, and 2 complex. Now I can't take 2 away from the negatives, so I reset it and take 2 away from the positives and repeat this here. 3 positives and 2 negatives gives us 5, telling me I'm missing 2. Subtract 2 from the negatives, so we could have 3 positive, 0 negative, and 4 complex, because again, they still have to add together to be 7. Can't take any away from the negatives, so I can reset it because I can take one last group of 2 from the positives. So I can have 1 positive, 2 negative, and 4 complex. And lastly, we could have 1 positive, 0 negative, which would mean we'd have to have 6 complex. And that there is our final answer for this here with Descartes' rule of signs. Because the total number of solutions need to be 7 each time in each of the rows. Because 5 plus 2 is 7. 5 plus 0 plus 2 is still 7. 3 plus 2 is 5, 6, 7. 3 plus 0 is 3, plus 4 is 7. 1 plus 2 is 3, plus 4 is 7. 1 plus 0 is 1, plus 6 is still 7. We still have that total of 7, which is our degree. All right, 29 through 34 solved. Now the first thing I would do with each one of these is I'd grab the graphing calculator, hit y equals, and if there is any equation in there, clear it out. And we're going to type that equation in. We're going to type it in exactly as we see it. I wouldn't change a thing. I'm just going to graph it. X to the 5th minus 20x cubed plus 20x squared minus 21x plus 20. Graph. We're going to see where it crosses the x-axis, and it crosses in 3 spots. Now, because the degree of the polynomial is 5, we need 2 less than the degree solutions for our answer, for what we're going to have a part of our answer. Now, because if we look at this here, it crossed at 3 spots. Our solutions are 4, 1, and negative 5. So x is equal to 4, 1, and negative 5. We have 3 of our 5 solutions. We have 3 of the values of x that will make this function equal 0. So we know these 3 values will work. We just need to now use synthetic division to bring it down from a quadratic to, or from a degree 5 down to a quadratic. And once we get it down to a quadratic, we can use that last equation to solve from there. There we go. So we're going to start this process here. So it doesn't matter which one we start with. I'm going to start with 1. Now we're going to put the coefficients across the top, 1 for x to the 5th. Now because there's not an x to the 4th term, we're going to put it in as 0. Negative 20 for x cubed, positive 20 for x squared. Negative 20, 1 for x, and then 20. We're going to bring the 1 down. Now 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 20 plus 1 is negative 19. 1 times negative 19 is negative 19. 20 plus negative 19 is 1. 1 times 1 is still 1. Negative 20 plus 1 is negative 20. Lastly, 1 times negative 20 is negative 20. And 20 plus negative 20 is 0, and that's what we wanted. We wanted that remainder to be 0. Now I would just go on and take the next number 4 and do this again. 4 times 1 is 4. 1 plus 4 is 5. 4 times 5 is 20. Negative 19 plus 20 is 1. 4 times 1 is 4. 1 plus 4 is 5. 4 times 5 is positive 20, and our negative 20 plus 20 is indeed 0. Just what we wanted. Now we do have one more solution, which is our negative 5. And we're going to do this one last time. Negative 5 times 1 is negative 5. 5 plus negative 5 is 0. Negative 5 times 0 is 0. 1 plus 0 is 1. Negative 5 times 1 is negative 5. And 5 plus negative 5 is 0. Now, because we've run out of solutions and we do have it down to a quadratic, we can go on and solve. The 0 is our remainder. The first one's our term without x. 0 is our term with x, and 1 is our term with x squared. Telling us the final expression is x squared plus 1, we're going to set it equal to 0 and solve. Now, because we don't have a term with just x, we can use the square root method. We can subtract 1 from both sides, telling us x squared is equal to negative 1. And lastly, we can take the square root of both sides, our square root, and x squared is going to simplify to x. And again, whenever we take the square root of both sides, we have to put the plus or minus. Now, the square root of negative 1 is I. That's just by definition. Another way we can look at it is the negative is going to come out as I, leaving us with the square root of 1, which is 1, telling us it's 1i, or just I. So the other two solutions are positive, negative I, telling us the solutions for problem number 29 are 4, negative 5, and plus and minus I. We will need all. Because degree 5 should be 5 solutions, 1, 2, 3, and this counts as 2 because the positive and negative. We have a total of 5. Our next one is this one here. 30 x to the 4th minus 6x cubed minus 7x squared plus 6x minus 8. So, degree 4, so we will have 4 solutions. I want at least 2. If I can get more than 2, that's even better. Minimum, we need 2. Better if we have 3. Best case scenario is we get all 4. So x to the 4th minus 6x cubed. Well, it's going to be helpful if I don't type everything into the exponent. X to the 4th minus 6x cubed plus 7x squared plus 6x minus 8. Graph. We see this here. We see it intersects the x-axis at 4 spots. And if I look at the table again, we're looking for what values of x make the function be 0. We're looking for what values of x make the y value be 0, not what values of y make the x values be 0. So at negative 1, the y value is 0. At 1, the y value is 0. At 2, the y value is 0. And at 4, the y value is 0. So negative 1, 1, 2, 4. Is what the graphing calculator shows. I have 1, 2, 3, 4 solutions. The degree is 4. I have 4 solutions. I am done. I do not have to do anything. I don't have to solve anything because the graphing calculator, we graphed it and found all 4 zeros. We're finished. We're moving on. X cubed minus 11x squared plus 41x minus 51. Again, I would just start off by graphing it. X cubed minus 11x squared plus 41x minus 51. We're going to graph it. Now, because it is a cubic, we're looking for at least one zero. Minimum what we need. And when x is 3, the y value is 0. So our solution is 3. Now, we need 3 solutions. There are 3 values of x that will make this be 0. And graphing only gave us 1. It only told us that x was 3. So we're going to have to use synthetic division. We're going to have to solve this all the way down. So I'm going to set up the synthetic division. We're going to do it with 3, and then solve the quadratic that we have remaining. Now, once we have it set up, we're going to do 3 times 1, which is 3. 11 plus 3 is going to give us negative 8. 3 times negative 8 is negative 24. 41 plus negative 24 is going to be 17. And again, we can do some of this in the calculator. So 41 plus negative 24 is 17. Just like we had. 3 times 17. 3 times 17, 51. And lastly, negative 51 plus 51 is 0, just like we wanted. Now, because we don't have any other zeros, we're going to fill our variables back in. That's our remainder. 17 is our term without x. 8 is our term with x, and 1 is our term with x squared. So we have x squared minus 8x plus 17 is equal to 0. Now at this point here, we do need to solve the remaining equation. For the values of x, that will make this function equal 0. Now at this point here, I'm just going to use quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now this does match up with our ax squared plus bx plus c. So we're going to fill in the values for a, b, and c and then simplify as far as possible. Now the value of a is the number in front of x squared. And it for us is 1 since there's not a number written. B is our number in front of x, which is negative 8. So we'll plug it into our 2 spots. And lastly, our value of c is positive 17. So what we have left is negative 8 plus or minus the square root of negative 8 squared minus 4 times 1 times 17 all over 2 times 1. Well, our negative 8 is going to make a positive 8. 2 times 1 on bottom is 2. Now I'm going to plug everything inside the radical into the calculator. Negative 8 squared minus 4 times 1 times 17. Do make sure when you plug this in to put parentheses around that negative 8. Negative 8 squared minus 4 times 1 times 17. And it's going to give us negative 4. Because if you don't put the parentheses around that negative 8 squared, it will give you a different answer. Now the square root of negative 4, that negative is going to come out as I. Now what that leaves us with is the square root of 4. Now the square root of 4 is 2, so it's telling us that the square root of negative 4 is 2i. Now because there is a greatest common factor of 2 across all 3, we will divide it out. And our 2 divided by 2 here is 1, so the denominator simplifies completely. The 8 divided by 2 is 4. 2i divided by 2 is just going to be I, telling us that the remaining 2 solutions is 4 plus or minus I. So we have 3 and 4 plus I and 4 minus I, and those would be our 3 solutions. Those would be the 3 values of x that would make this function equal 0. 32. 9m to the fifth minus 27m cubed. There are going to be 5 solutions, and funny enough, 0 is going to show up a lot. Now we can graph this. 9x to the fifth minus 27x to the third. Graph. Now we see it does cross at 2 places, and then it crosses at 0. Now, actually 0 has an odd multiplicity. It shows up a few times. So we're going to try 9 first. Now we have 9 for m to the fifth, 0 for m to the fourth because it's not there, negative 27 for m cubed. Now since we don't have an m squared, it's 0. Since we don't have an m to the first, it's 0. Since we don't have a constant term, it's 0. Now another way I can make sure I have the correct amount of terms, since the degree is 5, we should have 6 terms. 1, 2, 3, 4, 5, 6. Okay. We do have them all there. Bring the first number down. 9. So 0 times 9 is 0. 0 plus 0 is 0. 0 times 0 is 0. Negative 27 plus 0 is negative 27. 0 times negative 27 is 0. 0 plus 0 is 0. 0 times 0 is 0. 0 plus 0 is 0. 0 times 0 is 0. And 0 plus 0 is 0. Our last number is the remainder. So 0 is a solution. You know what? I'm going to do it again. 0 times 9 is 0. 0 plus 0 is 0. 0 times 0 is 0. Negative 27 plus 0 is negative 27. 0 times negative 27 is negative 27. Not negative 27. I am spacing. Is 0. 0 plus 0 is 0. 0 times 0 is 0. And lastly, 0 plus 0 is 0. Funny enough, it is actually going to work one more time. Zero times 9 is 0. 0 plus 0 is 0. 0 times 0 is 0. Negative 27 plus 0 is negative 27. 0 times negative 27 is 0. And 0 plus 0 is 0. Now we're down to a quadratic. Remainder. Term without m. 0 is our m to the first, and 9 is our m squared. Telling us that we have 9m squared minus 27. Now again, since we don't have a middle term, I don't have a term to the first power. We can use square root method. Square root method just says we get the term being squared by itself. So to do that, I would add 27 to both sides. Tell me 9m squared is equal to 27. Divide both sides by 9. Telling me m squared is equal to 3. That's 3. And since the m squared term is by itself, we can take the square root of both sides. The square and square would cancel, giving me m by itself. Plus or minus, because we took the square root of both sides, and since the square root of 3 does not reduce, it tells me that plus or minus the square root of 3. So I have 0, 0, 0, and plus or minus the square root of 3. Now, that is a good question. How do I know that 0 showed up 3 times? Well, 2 ways. 1, when there are no constant terms, there is only variables with every single expression, 0 is a solution. And funny enough, the biggest exponent will tell me how many, or the smallest exponent attached to variable will tell me how many times 0 shows up as a solution. Okay, another way I can look at it is I only have these 2 terms, so there is a greatest common factor among them. 9m cubed, because if I factor the 9 out of 9, we get 1. And if I factor m to the third out of m to the fifth, I'm actually left with m squared. Minus 9 factored out of 27 would be 3. M cubed factors out completely, telling me that I have really 9m to the third times m squared minus 3. 9m to the third Really, I'm just looking at m to the third, because we could say 9m to the third times is equal to 0, because our zero product property, and m squared is equal, m squared minus 3 is equal to 0. Really, 9m to the third, if I wanted to really break it down, we're saying we have 9 times m times m equals 0. I have 2 or more things multiplied together to equal 0, so one of these is going to have to actually equal 0. Really, all 3 of them are going to be 0. We're good there. M squared minus 3 equals 0. We can square root method, add 3 to both sides, telling me m squared is equal to 3. Square root both sides, m is equal to plus and minus the square root of 3. Most likely, on the problems on the test, we're not going to have one like this, but if we do, you now know how to solve it. Congrats. 33 and 34, the last two. This one is a cubic, so we should have 3 solutions. We should have 3 values of x that make the function be 0. So again, I'm going to graph it. Let's actually see what function is. 3x cubed plus x squared minus 38x plus 24. Graph. Hey, we do see it crosses some nice points. When x is 3, the y value is 0. That is a solution. And when x is negative 4, the y value is 0. Because again, when we graph, we're looking at what values of x make the y value be 0. And we have 3 and negative 4. We should have 3 solutions. We should have 3 values. So really, we just need to look for one more. We can do synthetic division to find it. We'll put one of the 2 values in the cubby. 3, excuse me. Put the numbers across the top. 3 for x to the third, 1 for x squared, negative 38. And 24 will drop the first number. 3 times 3 is 9. 1 plus 9 is 10. 3 times 10 is 30. Negative 38 plus 30 is negative 8. And 3 times negative 8 is negative 24. 24 plus negative 24 is 0. And we get this here. Now we're going to do it again with our other solution, which was negative 4. Negative 4 times 3 is negative 12. 10 plus negative 12 is negative 2. Negative 4 times negative 2 is positive 8. And 8 plus negative 8 is 0. Now we're going to fill our variables back in, telling us 3x minus 2 is 0. And we can solve for x. First thing we would do is add 2 to both sides. Minus 3x is equal to 2. Lastly, we would divide both sides by 3, telling us x is equal to 2/3. And that would be our other solution. And that's it. Those are all 3 solutions. It is a degree 3. We have 3. There are 3 solutions. So we're finished with this one here. And lo and behold, it brings us to the last problem. And again, type it in. 4x to the third minus 49x minus 60. Graph. We have this here. And again, since it is a cubic, we need 3 values of x. 3 solutions. And the calculator only gave us 1. When x is 4, the y value is 0. Because again, when we graph, we're looking for what values of x will make the y value be 0. And we want at least n minus 2, we're in its degree. So for degree 3, we need at least 1. If we find 2, that's even better, like the last one. For best possible scenario, the best thing that could happen is if we find all 3. If we find all 3, we're done. We don't have to do anything else. Now, numbers across the top, I am getting ahead of myself. 4 for x cubed. Since there is no x squared term, we have to fill it in as 0. Negative 49 for x, negative 60. We bring the 4 down. 4 times 4 is 16. 0 plus 16 is 16. 4 times 16 is 64. Negative 49 plus 64 is 15. 4 times 15 is 60. And negative 60 plus 60 is 0. Now we'll fill our variables back in. 0 is our remainder, 15 is our term without x, 16 is our term with x, and 4 is our term with x squared. So our final result is 4x squared plus 16x plus 15. Now up to this point, we're just going to go on quadratic formula to solve for the remaining variables. A is our term in front of x squared, so it's 4, so we'll plug 4 in its 2 spots. B is our term in front of x, so positive 16, it goes in its 2 spots. And C is 15, it goes in its 1 spot. Now we're going to simplify negative 16, well that's just negative 16. On bottom, 2 times 4 is 8. I'm going to plug everything inside the square root into the radical, so 16 squared minus 4 times 15. 16 squared minus 4 times 4 times 15 is 16. Now we need to simplify, because this will simplify. Negative 16 plus or minus, well, the square root of 16 is 4. Well then, that's simplified completely. Negative 16 and 4 are like terms. We can actually simplify this. We can actually take negative 16 plus 4 over 8. And we can also take negative 16 minus 4 over 8. And at this point here, if we want to do this by hand, we can do this by hand. Or we can do this in the calculator. If we did this by hand, negative 16 plus 4 is negative 12. And negative 12 over 8 is going to be negative 3/2. On the other side, negative 16 minus 4 is negative 20. And negative 20 over 8 does reduce to negative 5/2. So the last two are negative 3/2 and negative 5/2. Or I can say negative 16 plus 4 over 8, negative 3/2. Negative 16 minus 4 over 8, negative 5/2. So negative 3/2 and negative 5/2 are our other two solutions. And that is it, and that is everything on the review sheet. And we are finished.